Okay, let's do some questions here. Number one, we'll say we have 2 to the exponent 3x equals 1/2. Okay, and we're going to solve for x. What should we do here? Well, the strategy I would implore you to try is to make both the bases the same. So on the left here we have a base of 2, and it's to the 3x. And on the right, the base is currently a half, but we could change that to a base of 2, right? If you recall, 1/2 is the same as 2 to the negative 1. Okay, with this in mind, if 2 to the 3x equals 2 to the negative 1, that must mean that 3x is equal to negative 1, right? You can solve for x in this case, just divide both sides by 3. So x is equal to negative 1/3. Not too bad, right? Let's try another one. What if I have 8 to the exponent x minus 1 is equal to the cube root of 16? Well, first, let's recall that you can rewrite a radical like this as an exponent. You can say that's 16 to the exponent 1/3, right? And on the left you have 8 to the x minus 1. Now, let's do the same strategy we used over here. Let's try to change the bases to be the same. I can't make them both 8, right, or 16. That would be a little bit messy. But the easiest way to do this might be making both the bases into 2, because 8 is just 2 cubed, so 2 cubed to the x minus 1, and 16 is just 2 to the 4 to the 1/3, right? Just like that. From here, you can simplify the exponents. You can say 2 to the 3x minus 3, because you just multiply those exponents together, and that's going to equal 2 to the 4/3. From here, same as in the last question, once the bases are the same, you can equate the exponents. So 3x minus 3 equals 4/3. I would multiply everything here by 3, so you get 9x minus 9 equals 4. Bring that negative 9 to the other side. 9x equals 4 plus 9, which is 13. Divide both sides by 9. X equals 13 over 9. That should be your final answer. Okay? So once you get to this step, it's all just algebra all the way down. Just isolate for x. Okay, let's do another one. Let's say we have 2 to the x equals 17. How do you solve for x? Well, you can't really make 17 a base of 2, right? That would get a little bit tricky. But what you could do is you could take the log of both sides, right? Or the natural logarithm, whatever you want. Let's take the natural logarithm. Natural log of 2 to the x equals natural log of 17. This allows you to bring the x out of the exponent into the front, right? So x ln 2 equals ln 17. Now to get x by itself, just divide by ln 2. X equals ln 17 divided by ln of 2. So that's your exact answer. If you want to calculate what that is roughly, you'll get 4.087, something like that. Okay? Let's do another one. Let's say you have 30 times 5 to the x equals 150. Well, I'm tempted to do a similar thing as I just did. The problem being, though, there's this number attached to the front, so I want to get rid of that. So let's divide both sides by 30. You'll get 5x is equal to 5. Right? 150 divided by 30 is 5. So this is actually working out a little bit nicer than I thought it was going to, because this is just 5 to the 1, so that means x must equal 1, right? So already I get my answer. Okay, so let's go on to another question. Let's say I have 5 to the 1 minus x is equal to 10. What can I do here? Well, we'll take the natural log of both sides, right? Ln of 5 to the 1 minus x equals ln of 10. And then we'll bring this exponent to the front, right? So 1 minus x times ln of 5 equals ln of 10. And now to solve for x, you can divide both sides by ln 5. So 1 minus x equals natural log of 10 divided by the natural log of 5. Gotta get x by itself. So I'm going to move x to the right to make it positive, and I'm going to move this term to the left. So you'll get 1 minus ln of 10 over ln 5 is equal to x. And so that's the exact answer, but if you want to calculate it, you'll get negative 0.4307 approximately, okay? So it depends like what type of answer they're asking for. Do they want the exact answer, or do they want an approximate rounded answer, right, as a decimal? Okay, let's do another one. Let's say we have x equals log 3 to 43. Okay, let's just rewrite this as an exponential, right? Because why not? If they give you a logarithm, just rewrite it as an exponential. That means that 3 to the x equals 243, right? 3 to the x equals 243. That's just going around the horn, right? So we're asking ourselves 3 to what exponent gives us 243. Now, unless you're really familiar with all your exponents, you might have to do some trial and error here, right? You could take the log of both sides, but it seems like this is going to work out nicely. So just try a couple things. We know 3 cubed is 27, so it's got to be bigger than that. So you try 4, that doesn't work. You try 5, and as it turns out, x is equal to 5. 3 to the 5 equals 243. So it's okay if you have a simple one like this to just try some, trial and error. It takes you 1 or 2 guesses if you know where to start, right? If you're at least a little bit familiar with exponents. Let's do another one. Let's say x is equal to log base 2 of the 5th root of 8. What the heck does this mean? It means that 2 to the x equals the 5th root of 8. 2 to the x equals the 5th root of 8. Can I rewrite this as something a little bit more practical? Let's try 2 to the x equals 8 to the 1/5, right? Because that's the same thing. And now let's rewrite 8 as a base of 2. So 2 to the x equals 8 is 2 cubed to the 1/5. And then you can multiply those exponents together, right? 2 to the x equals 2 to the 3/5. Therefore, x equals 3/5. And that's your final answer. Okay, let's do another one. Let's do x equals log base 3 of 1 over root 3. So this means that 3 to the x equals 1 over root 3. Right, again, just going around the horn like that. Okay, now can I rewrite this to have the same base as this? Sure, why not, right? So 3 to the x equals, how do I write this with a base of 3? Well, I'm square rooting it. So the exponent on the 3 has to be a half. And it's also flipped upside down, so it's going to be negative a half. So if 3 to the x equals 3 to the negative 1/2, x must equal negative a half. Okay, let's do another one. Let's say I have 49 to the exponent x minus 1 is equal to 7 root 7. What the heck do I do here? Well, first we can write this 49 as a base of 7, right? I can say it's 7 squared x minus 1. And on the right, you can acknowledge that you have 7 to the 1 times 7 to the 1/2, right? Well, when you multiply things with the same base, you add the exponents. So you get 7 to the exponent 1 plus a half, which is 3 over 2. And then on the left, you have 7 to the exponent. Multiply those together, 2x minus 2. Now the bases are the same. You can equate the exponents, just like that. And then all you have to do is solve for x, right? Multiply it all by 2. 4x minus 4 equals 3. Bring that 4 over here. 3 plus 4 is 7. So 4x equals 7. Divide by 4. X equals 7 over 4. Not too bad, right? So again, try to make the bases the same if possible. For the next one, 2 to the 3x minus 4 equals 0.25. Well, first I can say 0.25 is just a quarter, right? And a quarter you could probably write as a base of 2, right? Because I know 4 is just 2 squared. So this whole thing will be 2 squared, but that square has to be negative because this is upside down, right? It's 1 over 4. So 2 to the negative 2 would give you a quarter. And then again, you have the same bases already. Equate the exponents. 3x minus 4 equals negative 2. You solve for x, and for this one, you're going to get x equals 2/3. Okay? Again, not too bad, just a little bit of algebra. Okay, next we have 9 to the exponent 2x plus 1 equals 81 times 27 to the x. So let's try to rewrite these all with the same base, right? 9 you could probably reduce to a base of 3, so 3 squared times 2x plus 1, like that. Over here, you have 81, well that's 3 to the 4, times 27, that's 3 to the 3 to the x, right? You can combine these together just by adding the exponents, right? Because this is 4, you combine these to be 3x, right? So you get 3 to the 4 plus 3x over here. And on the left, you have 3 to the, multiply those, 4x plus 2. Bases are the same. Equate the exponents. 4x plus 2 equals 4 plus 3x. And now we just have to solve for x, right? Bring your 3x to the left, 4x minus 3x. Bring this 2 to the right, 4 minus 2. You get x equals 2. Okay, let's do another one. Let's say you have 2 to the exponent 2x plus 2 plus 7 equals 71. Well, what I like to do is collect like terms. So if you have a number here and a number here, and they're both just regular numbers, put them on the same side, right? So bring that 7 over there. So you get 2 to the 2x plus 2 equals 71 minus 7, which is going to be 64. Rewrite 64 as a base of 2. That's 2 to the exponent 6. So now the bases are the same. 2x2 equals 6. Solve for x. X is going to equal 2. Okay. Next one. Log base x of 27 equals 3 over 2. What can I do here? Well, let's rewrite this as an exponent. X to the exponent 3 over 2 is equal to 27, right? You go around the horn like that. And how can I solve for x in this case? Well, rather than do trial and error, right, what I would say is get rid of the exponent on the x by putting an exponent on 27. What I mean by that is if you were to square both sides, which you can do, those would cancel, right? And if you take the cube root of both sides, or divide by 3 in the exponent, those would cancel. And so if you have x to the 3 over 2 equals 27, you could also write x equals 27 to the 2 over 3. That's another trick, right? And now this is something we can solve for because, and if you want, you can do this one at a time, right? Like you could say this is 27 to the 1/3 squared, because 27 to the 1/3 is 3, right? Cubed root of 27 is 3. So you get 3 squared, and that's equal to 9, right? So that's one way you could solve for this, and in my opinion, probably the easiest way to do it. Okay, let's do another question. Let's say you have log base 3 of 3x plus 2 equals 3. Again, rewrite it as an exponent. 3 to the 3 equals 3x plus 2. 3 cubed is 27 equals 3x plus 2. Bring the 2 to the other side. You get 25 equals 3x. Divide by 3. 25 over 3 is equal to x. And that's it. Log base 2 of x plus log base 2 of 3 is equal to 3. What should I do here? Well, this looks like a product rule, right? So you could combine these together. You could say log base 2 of 3 times x, right? So 3x equals 3. So now you could change this to an exponent, right? 2 to the 3 equals 3x. Well, 2 cubed is 8, so 8 equals 3x. Divide by 3, x equals 8/3. Right, not too bad. Let's do another. 3 log x minus log of 3 equals 2 log 3. Okay, so this looks like a product rule again, but we have these coefficients in the way, and we can't really use the product rule, or sorry, the quotient rule, because it's subtraction actually. But regardless, you can't use either of those rules until you move those coefficients out of the way. And so I'm going to use the power rule. I'm going to say this is log of x cubed minus log 3 equals log 3 squared. So I'm just moving those coefficients into the exponents, right? Just the power rule. From here, you can use the quotient rule, right? So you get log of x cubed over 3 equals log of 3 squared, which is 9. So if you have log of something equals log of something, you can equate those somethings, right? You could say x cubed over 3 is equal to 9. Multiply by 3, x cubed equals 27. Therefore, x is equal to 3, right? Because 3 cubed is 27. All right, and that's it. Okay, how about if we have log base 5 of 2x plus a half log base 5 of 9 equals 2. What should we do here? Well, these are both base 5, so we can use the product rule, but I want to move that coefficient into the exponent first. So log base 5 of 2x plus log base 5 of 9 to the 1/2 equals 2. Now we can combine these. So log base 5 of 2x times 9 to the 1/2 equals 2. And we can simplify that thing inside here, right? Because 9 to the 1/2, that's just square root of 9, which is 3. And 3 times 2 is going to be 6. So really what you have is log base 5 of 6x equals 2. Then you can rewrite this as an exponent. 5 to the 2 equals 6x. 5 to the 2 is 25. Divide both sides by 6. X equals 25 over 6. Let's say I have log base 6 of x plus log base 6 of x minus 5, and that's equal to 2. Well, this is another product rule, so you could have log base 6 of x times x minus 5 equals 2. Rewrite as an exponent. 6 squared equals x times x minus 5. And what you're going to get here is a little quadratic actually, because you're going to multiply out this right side. You'll get x squared minus 5x. You can bring that 6 squared to the right, which is really 36, so minus 36, set it to 0. And now we can solve for x, right? We just have to factor. So 0 equals what multiplies to negative 36 and adds to negative 5. I think you'll have x minus 9 and x plus 4, right? Simple trinomial factoring, sum product method. So you get two answers for x. You get x equals 9 and x equals negative 4. But let's remember, x is the number that we're taking log of, right? Like log base 6 of x. Well, as we said before, you can't take the log of a negative number because there's no number you could raise 6 to for an exponent to get a negative, right? So that negative 4 answer we got is invalid, right? That's just sort of a theoretical answer. It's not real. The real answer you have is x equals 9. Okay, so you always got to check if you get two answers because of some quadratic or something like that. If you get two answers, you got to verify that they both make sense. Negative 4 doesn't make sense, but 9 does. Okay, let's do another question. Let's say you have log base 9 of x equals log base 9 of 4 plus log base 9 of 5. Well, you can use the product rule on the right. You'll get log base 9 of x equals log base 9 of 4 times 5, which is 20. And this one's pretty straightforward, right? It means that x is equal to 20. Okay, that's it. Let's do another one. Let's do one that's a quotient rule. Let's say you have log of x minus log of 2 equals 3. Now I didn't write the bases here, so again, we assume they're 10 if we don't write the bases, right? So what do we have here? Well, you can use your quotient rule, right? You can say log base 10 of x over 2 is equal to 3, and then rewrite this as an exponent, right? 10 to the 3 equals x over 2. 10 to the 3 equals x over 2. 10 to the 3 is 1,000, right? 10 times 10 times 10, you get 1,000. Multiply both sides by 2 to get rid of it, and you get 2,000 equals x. Okay? Last one here. Let's do log of x equals 2 log of 8. What can you do here? Well, I can't get rid of those logs because there's a coefficient in the way. So what I'm going to do is use the power rule to move that into my exponent. So you get log of x equals log of 8 squared. Now you can cancel the logs. X equals 8 squared, therefore x equals 64. Okay, that's it. So hopefully all those questions gives you a good taste of what to expect in terms of logarithmic questions.